Alright, now let's take a look at the fourth problem on the practice exam. And okay, so it says estimate the number of square feet in Verdi Square below. So this is somewhere in Manhattan. I got this off Google Maps. And the legend is been cropped off, but this side of this figure we're going to assume is 120 feet. Alright, so this is kind of an open-ended question. I'm not sure that I'm really going to put this on the exam because everybody would get slightly different answers, right? Because what I want you to do is kind of just do some kind of hardcore estimating with like lengths of your pencil or something and figure out what all these other sides are. So you could do that. And I'm going to go ahead and do this problem the way I did it, but the way, depending on the measurements that you get, you might have slightly different values. But let's assume that for this side you get 235. Okay, so what did I do? I got this side, Broadway on Verdi Square, is like two of these 120 foot increments minus a little bit. So I say, well, it's probably about twice this minus 5 feet or something. So that's how I came up with 235. And this other side, Amsterdam Avenue, is almost exactly twice the 120 foot side, which I got by just measuring lengths of my pencil. So this is like 240. And 73rd Street side, I estimate this to be about 190. So I guess, how did I get that? I don't have a clue. Somehow I arrived at the number 190. So you might arrive at a slightly different number. Okay, and so the long and short of it is that I really want this problem to be an exercise in using something called Heron's theorem, which we haven't shown in class yet. But by the time you watch this, you might be extremely familiar with it. So the great thing about Heron's theorem is it gives the area of a triangle, any triangle, just in terms of the sides. It doesn't even have to be a right triangle. Okay, so we know that by side, 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 if we have three sides of a triangle, it really does determine the whole triangle, right? So there should be some way to get the area of the triangle just from these three numbers, A, B, C. And so this Greek mathematician Heron came up with a formula for computing that, and there's one in the book which has to do with something called the semi-perimeter. I haven't memorized the one in the book. The version of Heron's theorem that I've memorized is that the area of a triangle like this is equal to, the area is the square root of A plus B plus C. Okay, and now you just take turns making each one negative. I'm not going to have enough room here, I'm sorry. I'm going to have to write out the formula for Heron's theorem down here. So you have the three sides of the triangle A, B, C. A, B, C. Okay, and the area of the triangle in terms of the sides is the square root of, it's a fraction, and there is 16 on the bottom, and it goes A plus B plus C. And now you take turns making each one negative. Okay, so first A is negative, now it's B's turn to be negative. And now in the last one it is C's turn to be negative. Okay, alright. And so that's the formula. Notice that I don't have any triangles in this picture yet, but I can make a triangle by connecting, say, these two corners. You could connect the other two corners if you want. And when I measure this, what I get is about 300 feet. Oops. Okay, so I call this side 300. Now look, I just have two triangles. Let's say, call this triangle 1, which is, Broadway, 72nd Street, Amsterdam, and then I also have this other triangle over here, T2, alright, which is Broadway, Amsterdam, and 72nd. Okay, so the answer to this question is just the area of T1 plus the area of T2. Okay, so for each one of these separately, you use Heron's theorem to find these areas. Okay, so you just plug stuff in to this formula. So almost everything just happens in your calculator. But let's just write these things out really quick. I've already figured them out anyway. So the area for T1 is equal to, alright, so just plugging numbers in, you should get 655 times 185 times 415 times 55. Okay, so those correspond to these four pieces here. Whoops. Alright, and on the bottom is 16. And this turns out to be 13,147.76 square feet. And for the other triangle, T2, if you put those into Heron's theorem, you will get the numbers 730, 350, 250, and 130, and it will all be over 16. And this turns out to be equal to 22781 and a little change. And when you add these two things together, you get the answer, which is 35,928.99 square feet. Okay, so that is the approximate square footage of Verdi Square, where there is the Utopia Diner and looks like an Urban Outfitters next door. And that's the end of the question.